Okay. Good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay. Happy New Year to everybody. Okay. The date for this morning will be January 3, 2024, and the time is 1:24 a.m. My topic for this morning will be a long video format topic. It's a random topic. So this will be added to my random topic long video format on my channel. Okay, let's proceed. The title of the topic for this morning will be, this is with regard to trigonometry. So we are probing something here. It's a probing problem. It's just like we are given an identity, and the problem is asking for us to prove that the two given identities or the given identity are actually equivalent. Okay, let's proceed. The problem is prove that the given trigonometric equation or trigonometric identity, the sine of the quantity 90 degrees minus x close quantity is equal to cosine of x. This is 90 degrees. Okay. So we are to prove that the sine of the quantity 90 degrees minus x close quantity should be equal to cosine of x. I intend to bring out this one under long video format. So because the time duration for the short videos is uh, too small. The maximum is just actually only around 1 minute. So I want to bring out this one under long video format. Okay, let's try to bring out solution number one. Solution number one, since this is the study of trigonometry, we will be figuring out a right triangle here. So I bring out a right triangle here, in which this angle here, I refer this one as x. Okay, this is a right triangle. So if this is x, this angle here should be 90 degrees minus x. They are complementary, meaning the sum of this angle here plus this angle should be equal to 90 degrees. Okay, and we will designate this side here as A, this side here as side small b, and the hypotenuse to be side small c. If we try to refer to the given right triangle, if we try to take the sine of this, sine value, we will take the sine of 90 degrees minus x. We'll consider this angle here. If we try to consider this angle, this should be with the quantity. Okay? This side B here should be opposite side, and this side A here is adjacent side, considering the angle 90 degrees minus x. So if we try to take the sine of 90 degrees minus x, by definition, sine is actually opposite side over hypotenuse. So considering 90 degrees minus x, this is opposite side, and this is hypotenuse. So if we try to take the sine of 90 degrees minus x, it should be the ratio b over c. We call this one equation number one. Okay? Considering angle x. Okay? Considering angle x, this side B here should be its adjacent side. Okay? And this side A here should be its opposite side. So if we try to take the cosine of this angle here, cosine of angle x. If we try to take the cosine of angle x, Okay? By definition of a cosine, it should be adjacent over hypotenuse. But like what I said, considering angle x, its adjacent side is actually side B. So if we try to take the cosine of angle x, cosine of this, it should be side B over hypotenuse. So cosine of angle x will be equal to adjacent side. Its adjacent side is side B, and its hypotenuse is actually side C. So it will be the ratio B over C. That will be equation number 2. Okay? We will equate B over C should be equal to B over C using equation number 1 and number 2. So using equation number 1, the ratio B over C is actually sine of 90 degrees minus x. This is 90 degrees. This is 90 degrees minus x. Should be equal to the ratio B over C, considering equation number 2. And the equivalent of the ratio B over C, considering equation number 2, is actually cosine of x. So the right hand side will be cosine of x. Okay? And we have proven that the sine of the quantity 90 degrees minus x should be equal to cosine of angle x. It's true. Okay? It's correct. We have proven that the sine of the quantity 90 degrees minus x is equal to cosine of x. That will be solution number 1 by using the so-called illustration of a right triangle in which the angles are actually complementary. For solution number 2, the solution number 2 is actually the so-called use of the sine of a difference of two angles. If we try to notice the left-hand side, it is actually the difference of two angles, right? It is 90 degrees minus x. So the sine of 90 degrees minus x, this is 90 degrees. Okay? If we try to expand this one by using the sine of the difference of two angles, okay, it will be sine, cosine, cosine, sine, and if this is minus, this should be minus. Meaning to say, it will be the sine of the first angle times the cosine of the second angle, which is x, minus. If this is minus, this should be minus. Minus cosine of the first angle, which is 90 degrees, times the sine of the second angle is actually x. So if we try to simplify the right hand side, sine of 90 degrees is 1. Okay, for that one, I better get the new pen. Sine of 90 degrees is 1 times cosine of x. So this is cosine of x. This is minus, right? So this is minus. Cosine of 90 degrees is actually 0. Excuse me. Times sine of x. 1 times cosine of x is just pure cosine of x. Okay? And 0 times sine of x, this will become 0. So if we try to take the simplification of the right hand side, it will just be simply 1 times cosine of x, which is cosine of x. This is now 0. So it seems this is gone. Right? So meaning to say, the sine of the quantity 90 degrees minus x is actually cosine of x, and it is true. We have proven that the sine of the difference of 90 degrees minus x should be equal to cosine of x. That will be solution number 2. Okay, that's trigonometry. So for tonight, we have proven that the sine of 90 degrees minus x is equal to cosine of x. Solution number 1 is this one. Solution number 2 is this one by using the expansion of the sine of the difference of two angles. Okay. Good morning from Los Angeles. This is Professor David J. de los Reyes.